I think we're ready to kick off here. So we've got Matt Farina joining us. Matt, you there?
Hello, can you hear me?
Yes, I hear you well.
The first thing, the way you start every call, right? Can you hear me?
That's right. Everyone. Well, it's good to see you, man. Let's say I think we'll kick off and maybe we'll let's do introductions here for the first. Matt, I know you going back for your work that you did with Helm, and when I was a little bit more involved in that project, going quite a bit far back. But then, of course, now you're on the technical oversight committee, so you work with the CNCF. You're working with Rancher, and been there for a while. So have admired your work, but I don't think we've talked really too much in the last few years. So it's a good chance to kind of catch up. Did I miss anything in my introduction? How would you introduce yourself?
No, that's a fine way to do it. I work at Rancher I actually work at SUSE now that Rancher is part of SUSE on various things related to Rancher and all these different projects and things we have going on. I sit on the technical oversight committee, and I still do Helm stuff. I'm still one of the Helm maintainers. I'm active in Helm. I'm also active in Artifact Hub, if you're not familiar with Artifact Hub.
Yeah, Artifact Hub is I was thinking of the bar. What was that project called? That well, you introduced it. There was a project that was like for small artifacts. It was called like the bar or
Bundle
some,
Bar.
Bundle bar. Yeah, Bundle
Yes.
Bar, different project. So yeah, Artifact Hub. Do you want to introduce that as well?
Sure. Artifact Hub is a CNCF sandbox project, and you can go to artifacthub.io, and it lets you search and discover artifacts for various projects across the kind of the cloud native ecosystem. Most of those artifacts are CNCF ones, right? They might be related to Helm or OPA or any of these various things. But there's also Tecton chains in there and Tecton resources, and those are from the CD Foundation. The only things that's listed is stuff that's in a foundation somewhere, but it's a whole variety of different artifacts. You can find operators related to OLM. There's all kinds of stuff in there. Qborden recently is a new sandbox edition, and one of the first things they did was reached out to get their policies, which are WebAssembly stored in an OCI registry, listed on there so people can discover them, because these days everything's distributed, right? So if everything's distributed across repositories and registries all over the internet, how do you discover it? And that's Artifact Hub.
Yeah, and I think this is sort of maybe a spiritual successor, but expanded to what used to be just the main Helm repository, because we used to have just a single Helm repository, and then of course that cost an arm and a leg when it was all centralized, and it's been distributed now. So this is kind of the database so that anybody can search for Helm charts, but also Docker images or whatever now.
Well, Helm was originally designed to do repositories in a distributed manner. And the Helm folks said, hey, you know what? We need to have an example repository. So we're going to come up with a charts repository. It'll be an example for what people should do in their own distributed ones. And we're going to add it by default. So everybody's got this examples right there. That's great for a project getting started. And if somebody wants to pick up Helm and immediately make it useful as a new project out there, the onboarding experience was just fast and easy, right? I used to work with somebody who said, you want somebody to have fun in 5 minutes. They want to accomplish something useful, successful in the first 5 minutes they've picked it up. And Helm solved that with their onboarding experience way before it was popular, when it was brand new, all of that, right?
Yeah.
And everybody said, hey, I want my thing in this repository. And so it turned from an examples repository to the repository of all the charts, and everybody wanted their stuff in there. And then it grew and grew and grew, and it became unmaintainable because there was so much in it, and it required so many bodies to keep everything up. And so we went distributed. And then we had the Helm Hub to help you search for the distributed stuff. But the Helm Hub ran into scaling problems of its own. And so we knew we needed a second version of that. And instead of creating a second version of that, Artifact Hub came along and did Helm charts plus a whole bunch of other stuff.
I seem to remember, because this was actually back when I was doing some stuff with the Helm project. I remember looking at a bill in one of the maintainer meetings, and it was like, we're going to spend $1 million. It was something crazy like that. It was like, we're going to spend $1 million on this Helm repository this year because every CI/CD pipeline out there does a Helm update, and it hits this repo, and then it downloads all of this, just the index. And like the index wasn't that big, but it was like, because it happens so many times in so many places, even if people weren't installing stuff from the community one because it was there by default, it was like, oh, wow, this is really expensive. And so now everything's sort of distributed. You can just set up your own Helm repo, and GitHub makes it very easy to set up your own Helm repo now. And so then it's just all that cost, this cost is, I'm sure it's greater now. It's just distributed across lots and lots of people so that the cost feels very low.
Yeah, at the time, because Helm started out as a sub project. Well, Helm started out at Deis, and then Deis and Google got together and turned it into a sub project of Kubernetes. Then Kubernetes went into the CNCF, right? So this was all before
Were
it
you
went
a
into
part
the
of
CNCF.
the original Deis team?
No, I wasn't.
No, okay.
That was Matt Butcher who started it off over there. There's multiple Matts who work on
Those
Helm.
were the other Mats. I remember we used to call them the Mats.
Yeah.
It's a team.
And so it started off and it merged with something called Deployment Manager. That was a Kubernetes thing, and it became a Kubernetes sub project. And so this charts all ended up being graciously hosted out of Google before the CNCF existed. And so the charts and all of those downloads were being consumed by Google. Ate all of the costs for that. And so I thank Google for eating all of those costs for so many years on distributing that. And then we eventually migrated it as it was being shut down over to GitHub. And so GitHub now eats any legacy costs for that. So it got distributed from GitHub Microsoft now, and it used to be Google. But now it's distributed really all over the place with repositories everywhere that end up doing that, and OCI registries, right? So now there's also people putting charts in OCI registries, and those can be listed on Artifact Hub, which adds discoverability to it. And the OCI registries can be everywhere. Even Docker Hub recently added support for Helm charts in Docker Hub itself.
Yeah,
and their example when they said we're going to do artifacts was they showed Helm charts. So I was really excited about that.
Yeah, it was very cool. Well, so actually this is a good preamble, and I forgot to sort of kicking this thing off. For those that are just tuning in, welcome to GitOps the Planet. I am your host, Dan Garfield. I am the Chief Open Source Officer and co-founder of Codefresh, the CI/CD company that focuses on doing GitOps and continuous delivery for Kubernetes, progressive delivery. I'm an Argo maintainer. I contributed in the past to Helm, but not too much. And now we're doing this GitOps the Planet podcast, Twitch stream, where we just talk about all things GitOps. And today, Matt's joining us because we wanted to talk about GitOps at Edge. And this is something that when I first heard about it, blew my mind and got me very excited. Just Kubernetes at Edge in general, as it kicked off. And I remember finding out that people were now using, this was a few years ago, they were using Kubernetes clusters on those big shipping container boats that are out to sea to run all the services for the boat and actually manage navigation and all this stuff, because it had failover and it was declarative. It was easier to update. And so I loved the idea that we were actually shipping containers in the real world by using containers on these Kubernetes clusters at Edge. And since then, we've seen Kubernetes go to the edge at Starbucks, at Chick-fil-A. So a lot of people don't know it, but any day if they go to a Starbucks, they're actually hitting a Kubernetes cluster just by ordering a coffee, and they're hitting one that's local to the shop that they're at. Chick-fil-A has very famously talked about their use case where they have a Kubernetes cluster in every store, and so I have a Kubernetes cluster sitting right here. This is my Edge cluster. These are 3 of the nodes. I have a bunch of Atomic Pi nodes over there that you can't see, but this is running K3s, which has become the de facto most popular way to run Kubernetes at Edge. My stack is running with Argo CD. Chick-fil-A's is running with Argo CD. I think Starbucks uses a mix of Flux and Argo CD, depending on the use case. And then beyond just those retail storefronts, we also see 5G providers, folks like Verizon and others who are using Kubernetes at edge, and they're doing GitOps at edge. So I thought this would be a great topic to tackle with you, Matt, because of your work at Rancher and SUSE, where does that cover the diversity of use cases you've seen at edge, or am I just barely scratching the surface of what's happening at edge with Kubernetes?
I think you're just scratching the edge of what's happening here. And yeah, you're just scratching the surface of what's happening and what people are talking about. I've heard of situations with, Kubernetes in all kinds of different situations, mobile ones, container ships. There's so many other things out there that we're seeing it in there, or they're planning for Kubernetes in there with their next generation things. And so Kubernetes at the edge, I think, is just taking off, and I expect a pretty big explosion. It's hit maturity. A lot of those places are more of, they wait for something to really hit maturity and then have proven itself and be beaten up before they're ready to adopt it and trust it out there. And more of those organizations which have, lots of little edge locations, the Chick-fil-A type setups, that's going to be pretty common. That actually already is pretty common, and it's expanding. But there's more places like this that I think it's going to show up. And so then naturally, of course, when you've got stuff in all of these locations and you've got it maybe the same in every location, that screams GitOps. Or maybe you've got things that are a little bit different in the locations, but it can be configurable, or you want to try things. There's still lots of opportunities for GitOps in there to manage all of that, because when you go to scale, right, you need automation to manage that. It's nice, you got that cluster there. I've got one behind those doors behind me. And when you've got that, it's easy to manage on my own, right? If I've got, one cluster somewhere or one or two clusters, it's easy to hand roll those. When you go to edge, you now talk thousands of clusters for some of these cases. Think about, you bring up Chick-fil-A, right? You bring up Starbucks. How many store locations do they have? How many clusters do they have across their fleet? Now manage that at scale. That added complexity, especially when you probably still have fairly small teams that need to do this, means you need intelligent automation to help you do that, to remediate problems, to detect issues, and to hopefully successfully just continuously deploy these updates over time and keep those stores running. I mean, imagine if your transaction goes through a Kubernetes cluster and it goes down because of a bad update. Now that store, or more than one store, can't process, can't make money. That hurts. So you really want really smooth automation that keeps things up to date, doesn't fail. If something fails, gracefully falls back. You want to deal with all of this stuff in a really smart manner.
Yeah, I remember one time stopping in Reno at like a fast food joint, and they were like, hey, our payment systems are being updated right now, so we can't take any payments, so you can't buy anything. And I was like, I don't understand. What are you talking about? They're like, yeah, I don't know. There's a software update happening. And I was wondering, I was like, I wonder if that's because they have updated to Kubernetes and they forgot that they're rolling out an update during business hours, or if it's because they haven't and it's all centralized and it's just not being managed properly. But I definitely feel like there's just so much value in having that resiliency of Kubernetes, at edge, and then to manage it with GitOps. One of the interesting things that I've seen, and I wonder if you'll echo this, but I've actually seen air-gapped GitOps happening at edge. So they'll have a Kubernetes cluster in a location where it doesn't have internet access, and it's got Argo CD running. And basically what they'll do is they'll walk a thumb drive up, plug it in, and the thumb drive has a Git repo on it, and it has all the artifacts on it. And so as soon as they plug it in, this triggers reconciliation, where it looks at its source of truth, which is now the thumb drive, and reconciles everything into the Kubernetes cluster to update it. Really interesting use case. And for them, from what I've heard from the folks that were doing this, they were like, well, we liked the predictability of it. It's not scripts that run, right? It's, hey, the source of truth is available. Reconciliation is just going to happen. And they're going to get a green light at the end of the day telling them that reconciliation is working, that it's complete. And it's a lot easier for them to manage that way. Have you seen edge use cases like that where it's air gapped? Or I think it's less common, but I do see it.
I'm aware of air gap situations at the edge. I haven't heard of that exact update, but I have heard of DVDs being used to update things at the edge that are Kubernetes related.
Oh,
And
DVD,
that
wow.
boggled my mind, burning DVDs instead of a thumb drive, because a thumb drive seems a little bit more elegant. But
right.
the whole
Well,
idea of
I guess a DVD can't be modified. So maybe there's an advantage to that. There's no chance for someone to have stuck something else into the middle.
there you go. Yeah. But at the edge of figuring this out, we're going to have more and more air gap solutions. Or, with edge, it's the way connectivity works is interesting, right? Because working in the cloud, you kind of just expect connectivity to be there. But the further out you go, the worse connectivity goes, right? Stores for like Starbucks, okay, they're probably always connected unless like a line gets cut or there's a phone outage or something like that. But 99 point something percent of the time they're connected. But then go to that container ship at sea, right? That's probably connected over satellites. You get cloudy, you get other problems, and you run into issues out there, right? I've been on planes with satellite internet and had to go out just because of situations. And if you're running a cluster out there, now you don't have that connecting to the broader internet all the time. And if you did, right, look at the size of our container images these days, right? I remember at one of the keynotes at the KubeCon in Detroit, there was talk about the size of them, and it boggled my mind. There were some container images that are so big that modern registries won't accept them. They're just too
Really?
large for the registries to accept
Like
the return.
50 gigs? Is that what we're talking about?
Oh, you got to go bigger than that. I don't remember the numbers, but I think
Wow.
there was one over 100.
And it was like, maybe it was like a machine learning use case where they had just like a huge model as part of the image or something.
I think they just had a lot of stuff in there, if I remember right. But it
was a Windows container. That's just by
no.
default going to be huge.
Yeah, but when you get into what they can pull over the wire over something like satellite internet at sea, you also run into problems. So even if they do have connectivity there, you don't actually want to send everything that way.
Yeah.
Right? Because the bandwidth there, I mean, think of a cruise ship that has a cluster on it, right? They've got multimedia on there. They've got to load the new movies before they go out on trips. If they're doing that while they're out at sea, none of their paying customers on the ship can use the internet because it's saturated, pulling down updates all the time, right? So even in places where you've got somewhat internet, you need to have the ability to update these large files in there in your setups pretty easily. And then there's going to be times where you don't have any internet. Sometimes it's intentional, right? There's some companies who have clusters that are just cut off for security reasons. And right, I mean, there's situations out there where there are companies out there who will have a cluster of something and they won't even have a shared wall with another computer, right? Because the security is so locked down.
Yeah, there's what's that called? There, I remember reading about it. There was, I think it's Van Eck freaking, which is basically trying to listen in on the signals within a computer in a local area in order to decipher what's going on in there. And I've never seen it in real life before, but yeah, I mean, those are high security situations. Like,
and so if you've got Kubernetes and then GitOps in these situations, you've got to have just so many different ways to distribute those updates for those variety of situations.
Yeah, I've seen one of the things that we started doing is you basically have pipelines that are your artifacts are signed using something like cosign, because that can be added to your registry. And then you have security policies that are checking against keys. So you can say, hey, I want to make sure any artifact that I deploy, I know the key that I need to check. And so that means nothing can ever get onto my edge cluster that hasn't been signed properly and the chain of custody is correct.
Oh yeah, yeah. In fact, supply chain hacking attempts. So the CNCF has multiple security projects, and Justin Kapos is a professor at NYU. He's one of the guys behind it and maintainer and developer on some of these security projects. And he does a quiz, right, in some of his sessions, and he'll put up all these big names. And he'll quiz people. What do they all have in common? It's open source projects, big companies, little well-known companies, and they've all been hacked through their supply chain.
Wow.
And so supply chain security is a really common avenue. And now if you're running stuff at the edge, right, in your stores, get your business critical information in people's homes, right? You really want to make sure that you've done what you can to make sure that that is really secure. And in a lot of traditional computing spaces, a lot of work has been done there already, right? Things we're now bringing into the cloud native space, there have been solutions for in traditional space for years and years. And now we're starting to bring those in. And so it's nice to see more and more of that come in because it now touches more and more of our everyday lives.
Yeah, the two solutions I've used the most are Open Policy Agent, which basically uses ingestion webhooks to check everything coming onto the cluster, and it can reject it if it doesn't meet security policy. And the other is Kyverno, which I found was a newer project, but had kind of an easier syntax, and also same thing. I could use both of them to check for cosign signatures or to enforce other policy. Are there other projects you're aware of that are doing interesting security work on policy enforcement or OCI signing or those kinds of things?
It's like you tee me up for something like this. Do you know what I'm going to talk about here?
No, I have no idea.
You have no idea. So
I just feel like you know a lot of things, and so I just I'm just going to plumb the depths.
Yeah. So one of the other hot things these days is actually WebAssembly, right?
Oh
And
yeah.
so
WASMs.
WebAssembly and policies. So one of the recent sandbox additions to the CNCF that was actually developed at SUSE by one of my colleagues is a mutating admission controller that lets you write policies in any language, compile them to WebAssembly, and then run them. And so it takes that idea of OPA and Kyverno, but now says, hey, you want to have a real programming language to write your policies in? If it can compile to WebAssembly, go ahead. And they have SDKs and details for a bunch of common languages like Go and Rust and some of these things.
Is this
to help you get
just part of
started.
the WebAssembly project, or is this another?
No, this is a
sub-project?
CNCF project now. It's a CNCF sandbox project called KubeWarden and KubeWarden, and it will let you write something in a language of your choice. I could go write a policy in Go and then compile it to WebAssembly and use it. And of course, you store those in OCI registries. And you can, of course, you co-sign and all of this for signing and verification. They've even done examples of using GitHub Actions to sign your stuff so then you can verify it in there, right? But it's one of those new projects, KubeWarden, and it'll actually take things working in Rego, that you'd use with something like Gatekeeper. You can actually convert that to WebAssembly and use it with it. And they've got documentation and details on that. So you can take those existing policies people already use today, use them with it, or you can create your own policies. And if, your shop's a JavaScript shop or a Go shop or a Rust shop, you can write it in the language that works for you.
So the advantages are that you can just write it in a language that works for you. But the other advantage is you don't necessarily have to use something like OPA Gatekeeper because it's just a WASM that you can install kind of independently.
Yeah. And it'll actually take those existing policies. So if you've got something for OPA that's written in Rego, you can then go ahead and use it here too. So the existing policies work. And if you want to write your own policies, you can do something maybe a little bit more complicated that you would do with a programming language.
Oh, very interesting. Yeah, there's been a lot of discussion about WebAssembly and WASMs, and it's like I saw somebody that was like 2023 will be the year of the WASM, and it seems like just policy enforcement in general. But I had only seen it primarily for uses with like ingress controllers or like just general networking policy. I hadn't seen it being used to do something like this as like an injection check, like to check to see if there's signatures on images and that kind of thing.
You can do all of that with it. They already have policies for it. Those policies you
Wow.
can find in Artifact Hub, and they're all you store the policies in an OCR registry. So that same place you put your container images or everything else, you can also store your policies to be pulled down and used. So it works with that existing ecosystem. In fact, I think WebAssembly, to sidebar more on Edge than GitOps at Edge, is going to take off at Edge, because I can compile something to WebAssembly once, and I can run it on Windows, Mac, Linux, BSD, right? I can run it all over the place. I
And
can
it's
run
very
it on
lightweight.
ARM. I can run it on, Intel. There's some weird 32-bit chips that I even forget the names for that are used in some of these edge environments, and they've got WebAssembly execution engines on them. And so
Wow.
there's all of these places, and it's that same one artifact I can run everywhere, right? I don't have
Is it
to rebuild it for each target OS and architecture.
so it's not like a Docker image, because a Docker image I need
Yeah.
to build specifically for all these architectures. I can reference it from a single, URL, and I'll get the
Single
right
blob,
architecture.
that single blob will run everywhere.
Wow.
And so, and it's smaller. A lot of times when you compile it down, I've heard of some stuff where they took an existing thing, they put in a Docker image that had to have certain underlying runtime things there in the OS. And then they turned the same thing into WebAssembly, and it was about 1/10 the size. So you're distributing something smaller. It can run in multiple architectures. That's a lot easier when you're going into the edge, where you have less system resources, less hard drive space. You
Yeah.
want something smaller. You also, right, thinking back to the microkernels, people wanted a smaller kernel API for applications to interact with. With WebAssembly, you can kind of control the API that's available to the unit running. So it's more sandboxed, and it has more of a limited API you can then control there. So there's a lot there. Now there's more work you got to do. It's very fresh and it's very new, right? But those possibilities are one of the things that make it interesting for something like at the edge or something like that. And so that's why people see more possibility for it coming in the future.
Yeah, the Codefresh team was recently working on a project with a customer that involved a thousands of Kubernetes clusters that were mobile. They were
Yeah.
moving around and with changing levels of internet connectivity, and they had very, very strict resource requirements. So everything that we put on, to run the GitOps components needed to be super streamlined, super thin. One of the concerns I've heard about WebAssembly is it is very small, but there's if you start to stack them up a bit, there's a worry about how performant they are on requests. Because if you stick an extra 10 milliseconds on a request, this, when you're trying to stay pretty quick on responsive time and stuff, is that something that you have concerns about or have seen as an issue?
Not so far. Again, it'll probably come down just to certain use cases and how people write things and what they do. But I haven't actually seen that. And there are some websites and web apps out there today that are wholly served as WebAssembly. And if you went to their site or their app, you wouldn't even notice it.
Really? Wow. So
So
they're literally only using WebAssembly to run the service.
yes. And some of the WebAssembly startups have decided, hey, we are going to sip our own champagne and do this. And so when you go start poking around their site to learn more about them, you're actually seeing stuff generated and worked out in WebAssembly, and you don't know it, but they're sipping their own champagne there. And it's performant as all get out and can handle, stuff at scale, or at least the scale they're seeing.
I like sipping your own champagne more than eating your own dog food, because I've never wanted to eat dog food, and champagne sounds considerably more pleasant.
It does, and it sounds like what you've got is maybe more delicious, at
Yeah.
least to us.
No, we're making something actually good that we want to drink.
Yeah.
That's pretty amazing. I mean, so is this something that SUSE Rancher is doing with some of your edge offerings? Are you starting to do some WASM stuff with K3s? And I mean,
We don't
I guess
have
maybe
anything
it's just
coming to market
pass-through.
right now with it. We've definitely done some proof of concepts with it. I've wired up some of the WebAssembly stuff with Rancher Desktop just to see, instead of just running container images, what would it like to be to run WebAssembly along with it? And my prototypes had things working, but that whole environment underneath it and around it, what they were doing is changing. Like if you look at it, it used to be you'd plug a WebAssembly runtime in instead of a kubelet to work with Kubernetes. And now that community doing the work has changed the way they do it. Instead of plugging in at the kubelet level, it's now a container D plugin. So instead of having to re-implement your CNIs and, for storage and all of this to work with WebAssembly, all of that works with container D. They just made it plug in with as a plugin there instead of run C. And I think it's called run WASI. And it's actually now a sub project of container D in the CNCF. So they're starting to make progress for how they do it as they learn. And so my experiments were early on. Things are constantly changing. And so I'm sure we're going to circle back to this in the future because I see it there. And there are things we are already doing with WebAssembly, such as what we did with KubeWarden for policies, right? We see an opportunity right there with small policies that gives you a lot of power of a programming language, but how do you deal with all of this? And so that's where KubeWarden came along. And so we're starting there and we're waiting. There's just a lot going on in the WebAssembly space, which is why people are saying more 2023 will be a big year for it, because a bunch of those things we expect to hit a certain level of maturity in 2023, which means now people can do more interesting things on them.
Yeah, and I imagine that moving it into container D is more performant and scalable than trying to attach off of kubelet and kind of abuse the node level kubelet for all that stuff.
And it lets things interact with each other a little bit better. It's a smaller surface area that you have to maintain. As somebody who's maintained a lot of software, having a smaller surface area to maintain and keep up with sounds really nice.
And a better security profile.
Yeah.
Well, so to shift gears a little bit, one of the things that I had kind of earmarked to talk about with you is Fleet. And I was curious, I've used Fleet a little bit. I did just a little bit of poking around with it just to kind of get a feel for it. But what surprised me the most was seeing people use Fleet with Argo CD, because I would have thought that they were competitive, but instead it was sort of like, oh no, we use Fleet for a different purpose. Then we use Argo CD on each individual edge cluster to actually synchronize and deploy software there. So I wanted to ask you what the ideal pattern is for bootstrapping in a GitOps fashion using Fleet. Do you create a template with what's going to, like, do you start with a K3s cluster and you throw Fleet at that, or what's the order of operations, I suppose?
So, I mean, Fleet came out of Rancher, right? And so the idea was, well, if you're going to create and manage your clusters, you're going to do that with Rancher. And then you can come Fleet to come along to help you with your workloads. In fact, Rancher itself uses Fleet under the hood to manage its own workloads in the particular clusters. But you can run Fleet standalone too. But you've got your clusters and you install Fleet, and there's a couple of different ways. So Fleet works a little bit different than Argo, right? So you'll have a Fleet master, which watches your Git repositories to see here's what's going on, to look for changes, to receive webhooks if there's, a change from there, and just to see what's going on with the state of things. And then, so you've got the master, but in each cluster that you're doing something in that you need to manage, we have an agent in there. And that agent connects back to the master to get updates, right? And so it does a pull-based model from your downstream clusters back to the master to get updates. So if my master is, running out in AWS and, on my own network behind my firewall, I'm running a Kubernetes cluster, it can phone home, or that server, right, in AWS can't connect back in, it can't route back in, but my back home can phone home, keep a watch on, are there any updates, what needs to happen, reconcile off of that in order to apply things. And so Fleet works that way, right? It's sort of similar to Argo, right? Where your master will watch, but in your traditional Argo sense, it pushes out updates to the clusters it's managing. And in the Fleet sense, it works the opposite direction. And That's, I think, useful for at the edge, right? Because say you can't push because there's a network that's down. Well, then your edge thing can reconcile when it comes back up. Or maybe your edge components don't have network access, right? You've got all of these stores and they don't put every store in the open internet. You know, the IP for that can't be routed to. So what do? You can actually have your agent for Fleet running in each of those clusters, and it'll phone home back to the master that's on the internet and get its updates and know what to do. And so it can reconcile this way. In fact, Fleet was actually created because Argo did that more push out to what's under master, and we needed that pull. Darren, who originally started this, needed that pull from the clusters. So he built an agent system. And otherwise, it's actually fairly similar to Argo CD in the way a master watches for updates conceptually. And so that's kind of where it came from. We needed to have those agents that pulled rather than pushed. And Flux was a little bit simpler than what we needed. Argo did the push model. We, out to the clusters being managed, and we needed that pull model for those clusters because they may not be network accessible to what was pushing.
Yeah.
And so to fit that situation, that's where Darren created Fleet from, to meet that model. And so I can see how it would pair with Argo then, because it sort of like CD, so it fits with those other things. But there's also times where you just get various setups that I found, right? You'll get somebody who will be maybe using Fleet to manage their infrastructure components, and then their end user apps they're running are managed with something like Argo. And you'll have two different CD models depending on the organization that's doing what's going on here. Or maybe you've got some of the Argo components, not CD, that are being paired with Fleet, so you can get the pull model on this. There's various ways that it can intermix because it was inspired by Argo, and it's conceptually similar to a lot of what's going on.
Yeah, this is what I've seen at some companies is they basically use Fleet to bootstrap Argo CD onto each individual cluster. So then they are really performing like that total pull-based model where they're operating completely independently.
Yeah.
But the advantage, it seemed like, was that with Fleet, it was easier for them to roll out changes in a predictable manner. So they could say, like, roll these changes out to 10% of my clusters. Let's see how that goes. Okay, now let's roll it out to the rest of them and have some kind of a progressive delivery solution within the Fleet. And that seemed like it was one of the key features. Is that right? Or do I misunderstand how Fleet works?
A little bit misunderstanding, but there are some nice features about deploying some of this out there. Fleet is, so we've got a nice roadmap for Fleet. So Fleet was originally developed by Darren over a weekend or a week.
Darren Shepherd,
who was one of the founders of Rancher. And he developed a lot of what is Rancher and the subcomponents that are there today. And so he developed.
I'm hoping to have him on the show in January, by the way.
Oh, that'll be great. So he developed it fairly quickly, and put it out there. And then that was one of his projects. Now it moved from being his project. Now it's actually managed by a dedicated team, but he threw it together pretty quickly and got it up and running. And now we've been adding features and rounding out maturity and getting into pace. So you get something like Argo and you get Flux. They're now both, in fact, in the last few weeks, graduated CNCF projects, right? Fleet is now getting to that a much better point of maturity along the way over the last 6 to 9 months. But it wasn't there months ago, right? If you came to it 9 months ago, it was a little bit more raw. And so we've been adding a number of these features to bring it up to par. And it's in a lot better shape, but you can use it to manage those various things, to roll things out a little bit more predictably. A lot of stuff in the Fleet configuration, right, in your Git repository is pretty simple to follow because you can have Helm charts, you can have customers, you can have all of it in there, along with some things that let you tune it in the Fleet YAML. And it's pretty simple to roll it out to lots and lots of clusters. And because it's used by Rancher itself to manage things that Rancher is managing in there, right? So if somebody's using Rancher and they're managing hundreds of clusters and there's little bits Rancher's got in each of those clusters to make things happen, you wonder, how do those updates happen? Under the hood, it's using Fleet. And so we've made it to tune for that Rancher case, predictable, able to handle all that scale and that rollout. I can see how it would be useful for rolling out those other bits as well.
So is the order of operations then is I need to start with a cluster bootstrapped somewhere, and then I install the agent, and it will then grab information from the master, sync what it needs to sync onto the cluster, and go from there and register itself and report its information back into the control plane.
Yeah, there's a couple of ways. You really need to just stand up Fleet the master, which is a simple Helm install. And then you're going to create some custom resources to say, here's this Git repository, watch it. And as far as registering clusters you want to manage, you can either install an agent into the cluster and tell it where the master is, or you can create a custom resource for the cluster on the master and say, here's your basic information to connect to it and get started, and it'll go install the agent. And once the agent's installed with upgrades and everything, it'll keep the agents up to date along the way. And then the agents will be able to get updates from that master from then on out.
One of the interesting features that is currently in development within Argo, I think we're shooting for a release of Argo 2.6. I think that release just kicked off, and the process for releasing it before the end of the year is going on. This is not going to be in 2.6. I don't know if it'll be in 2.7. It's a little bit early days on this project, but a lot of the code has already been implemented. But they're taking application sets. Are you familiar with application sets in Argo CD?
No, refresh my memory.
So
I've read about them, but refresh my memory.
A little bit different than Flux. So within Argo, you have the concept of an application, which you can think of as a policy, which says, this is the source of truth. This is where I want it to go. These are the circumstances. These are the extra information. Before you sync it, I want you to run these things. After you sync it, I want you to run those things. This is all within the concept of an application. So whereas like within Flux, and I believe, and correct me if I'm wrong here, but within Flux, you do have some policy within that application, but everything really is generated. All of the manifests and things are generated kind of upfront within Helm or customized. And the way that Argo works, to have these applications, you can have an app of apps. So you can have an application that, because an application is just a Kubernetes custom resource. So you can have an application that syncs the manifests that represent other applications. So that's an app of apps. But then you also have the concept of an application set. And an application set lets you say, I want you to look at this directory structure. And based on all the folders that are there, I want you to generate an application for each folder. Or you can say, look at this Git repository. And every time there's a pull request, generate an application based on that pull request. And there are all these kinds of different generators. And basically, they just generate applications for Argo CD, which then trigger synchronization and all these things to happen. So this is really valuable if you have, like, let's say I have 1,000 clusters. I can use a cluster generator and say, I want 1,000 apps, one for each one of these clusters that has whatever little variation based on the cluster information from it. Does that all make sense?
Yes.
So there's this feature being worked on that will allow, I think right now it's being called, and it's a little bit of a confusing name, but it's being called application set rollouts. And basically what it lets you do is say, I have an application set and I want to define a rollout policy for updating those applications. So I have 1,000 applications and they're all identical, but they're going to different clusters, for example. I have a deployment policy that says roll these out 10% at a time, run these tests against those clusters, and make sure that all those apps have synced correctly before continuing the rollout along the way. So you can do a fully declarative fleet management style rollout. Is that something that you see as complementary to what Fleet is already doing? Or does it sound like more of an overlap of something that Fleet accomplishes?
A little overlap. So Fleet has, when it comes to grouping of things, right? Fleet will kind of do this already. So it's got bundles and you can kind of specify those using your Fleet YAML or with Helm charts, because it's very, very Helm centric. Darren was always a very Helm centric guy. And so it was built in a very Helm centric manner. And then for your bundles, which each Fleet YAML file specifies a bundle, it doesn't do it automatically. You have to manually specify it. You can have a rollout strategy, right? So you can say how many unavailable when it's doing the updates, all of those different things. You can partition things based on selectors. There's the whole rollout
Different
strategy.
geographies or
Yeah.
whatever.
So you can do that kind of thing with it, but it doesn't do the automatically. You create your own fleet YAMLs in order to specify where things are, and those are bundles. And so it's a little bit more manual than automated, but it's explicit rather than implicit. Is kind of the difference. One, it sounds like an application set of look at all these directories and create an application for it. That's implicitly figuring out what you want based on the directory structure. And Fleet's a little bit more explicit by having a Fleet YAMLs, and you specify them. And if you want to deal with things like ordering, like this thing needs to come up before this other thing, because Kubernetes, it's supposed to be declarative, but there's lots of little places that need to be imperative. And sometimes it has to do with Kubernetes, and a lot of the times it has to do with applications, right? Well, we're getting to this GitOps world, and it's great. We're going to throw stuff at Kubernetes, and it's going to reconcile till things come up. It actually assumes that your applications are written in a manner that works well for, right? If your application is in a deployment and it's got to jump around between different nodes, it has to handle that, right? And it has to be able to handle clean updates. I remember it just reminded me of something we were talking about before with updates. I remember back when I worked on Drupal back in the day, which is a content management system.
Gosh. Yeah.
And every time there's an update, the Drupal site goes offline for a brief period while it does an update. You can't have zero downtime updates. And that has to do with the way the application itself is coded, right? And so, there's a lot of little things going on here. But to circle back to it, yeah, in Fleet, it's a little bit explicit. And in that explicitness, you have the ability to say ordering of dependencies and things like that, rather than it sounds like implicit with this feature in Argo.
Yeah, interesting. Yeah, very interesting. So going into some of the other Rancher offerings, we mentioned K3s as being, I use it. I think it's the de facto way to run Kubernetes at edge. Is there anything exciting coming up with K3s, or is that just like, hey man, that project is boring now because it just works and there's nothing. It's just, we're going to deliver Kubernetes and it's exactly what you want. It's a commodity at this point. And it's not an insult. I mean, that's like, we all endeavor to make software that eventually becomes boring. You know what I mean?
We do have exciting stuff coming out of Rancher. So Rancher donated that to the CNCF. And in many ways, it is boring. And even the things they're going to go do and add to it, in the grand scheme of things, they're around the parts that are usually boring, the security things. Everybody cares about security. So there's going to be more little bits in there to improve stuff around that and portability and that kind of thing. But a lot of that
system upgrade controller. I love managing my Kubernetes version using Argo CD and GitOps with the system upgrade controller, and I can just bump the version and it just syncs and it takes care of it.
Isn't it great? And so little stuff like this, like that's something that was developed at Rancher, because the system upgrade controller is something that we use at Rancher for our stuff. And so I think that's more into the boring space, but it's that super useful thing. It's like hammers, they're boring. But if you're going to go build a house, you want a hammer, right?
Yeah.
It's gotten to the space where there's going to be little alterations to it, little jumps, but it's kind of that natural growth in the space rather than something wowzers.
And what about K3 OS? Because when I first started, maybe this is gone now, but when I first started, I was like, oh, I should be using their operating system, their Linux distribution. And I ended up finding that it was super streamlined, but kind of difficult to work with because I had to know all my requirements ahead of time. And I was doing like Plex transcoding on Kubernetes, and I needed to install these additional drivers, and I found it a little bit challenging to work with. So I ended up not using K3 OS. Is that a project that's still active and doing anything?
No, not really. If you want to look at OSs, right? So when SUSE bought Rancher, what did SUSE always do really well? Linux distributions. So there wasn't much of a need for us to have Linux distributions in the Rancher business because we had this other business, and they are, I mean, they've been doing it for decades. SUSE just hit 30 years in the Linux business. That's a long time. And so over the years, they've figured out how to do things. They have one of the most certified Linux distributions around security. The way they build our stuff and our build service, it's ridiculous compared to other distributions in security.
Which
And
distribution is that?
so we have SLE, SUSE Linux, enterprise SLE. SLES is what most people use, which is the server edition. That is one where you pay for support. If you get OpenSUSE, that's the one more people will probably be familiar with, because it's the one you go grab and just run with today. It's the one you're not paying for support with, but you can just take off and go to town with. But OpenSUSE is the one I'd have people look at. But we also have what we call the base container images. And that's more where we're into now for when we need something for our images. But Rancher runs on everything. All of our stuff will run on everything. K3S, you take that and it's designed to have all of the dependencies it needs. It needs a modern Linux, semi-modern Linux kernel, and everything else it should have bundled with it. So I can go drop that thing on, RHEL, Ubuntu, Debian, OpenSUSE, Rocky. It doesn't matter. It'll just come up and work. And
so it's a well integrated ecosystem within SUSE, but it's not an enforced ecosystem. I can use the components that I want to use.
Yeah, and well, that's an upstream project. We can't enforce, a particular Linux distro. So the CNCF can't favor a vendor, right? You can't say, oh, it's just going to work well with this vendor. You can't do vendor favoritism, because the CNCF is run by lots of competing vendors, and projects that did that aren't going to go over well. So you don't have that you can't have that vendor favoritism in projects. And so SUSE, it'll work well. We've got base container images. In fact, what I love about them, because I'm a bit of a security nerd, is at any given point I'll go run a scan on them with Trivy, and I'm going to find 0 CVEs, because SUSE is so great at CVEs announced, boom, the patch is released, it's fixed.
Oh, that's
just
awesome.
Shortly thereafter announcement.
I was stressed out this morning about this Atlassian 0 day because there's cookie leaking and people are jacking into Jira instances in the cloud and stuff, which is causing me stress. But
not know about this.
Well, the problem was somebody disclosed that they had been hacked, and then as part of the investigation, it came out that they had an issue with Jira, and I think it turned out to be a 0 day for all of Jira. So anyway, something else that I was curious about, and this is a little bit more tangential to GitOps, but in the past, Rancher bundled this sort of managed version of Jenkins, and there was a decision made to divest from that and recommend third-party CIs. And Rancher, as a partner of Codefresh, was very kind, and they said, hey, we encourage you, as you move away from our Rancher Jenkins pipelines, go use Codefresh. They work great with our stuff. So I was really thrilled about that. But I was kind of curious about, like, I guess coming at this from a CI/CD company, where I feel like so much developer experience is part of interacting with CI/CD. Do you think that Rancher is separating out developer experience from like operator experience, and maybe they're more focused on the latter? Or do you feel like there's still a big developer experience story there?
I think it depends.
And this is a really bizarre question that is way out of left field. And if you don't want to answer it, you don't have to.
I'm very comfortable talking to this question, so I'm happy to talk to it. So Rancher has often targeted that operator, right? Who's got to operate just a bunch of Kubernetes clusters and keep them up and running and help them manage it really well. And we deprecated that, Rancher pipelines that was based on Jenkins, because, when you look at it, CI/CD systems are personal to companies. Sometimes you step in, they've already got a company-wide one. They don't need something new. Sometimes they're really particular. Some people love Jenkins. Some people hate it. Some people are building something on top of Tecton. Some people are using Codefresh. There's lots of options out there for what people are going to use. And we can't dictate that to people. And a lot of companies already have something that they're using, somebody that they're happy with. And so for us to come in with something and say, hey, use this, it's like, but we've already got something. So why bother? So we want to play well with all of their CI/CD systems. And so we are going after developers, and you're going to see we're going to do more things to help with that. If you look at recent versions of Rancher, our whole dashboard experience has gotten a lot better for developers. Somebody wants to go in and explore the clusters, right? I want to go explore the resources in a particular cluster. I can go look at them. I can go check on things right through a user interface. That's pretty easy to use. And that's something, 2 years ago, 3 years ago, Rancher didn't have. The experience around navigating your resources, understanding what's going on in your clusters. And this is going to be important for developers who are saying, how does my thing actually run, right? Because the developers who don't worry about that stuff are just, I'm writing code, it'll run anywhere, somebody else's problem to make it run somewhere. But the people who actually have to run it in a cluster and understand that, that's dev to DevOps. There's lots there. So we've done that. We've got more things coming, Kubewarden kind of highlighted, okay, the developers want to deal with policies. Sure, write it in your language, compile it to WebAssembly, and it works. And I think this is great because there's a lot of developers who are getting tired of writing YAML all the time. They can actually write some of their policies in languages. And so we've got lots of little things coming along. We've got a Pino, which is a PaaS that's in Kubernetes and plays along with everything. And that's one of the newer projects that we have out of SUSE. And it's that more traditional style PaaS. So I can write my code, I can push it, and I can just run it. And so we are focused on the developer, but we're looking at where the developer's at and where those differentiators are. And if a lot of modern companies already have, CI/CD systems, who are we to come in and say, hey, we've got this one, don't use Codefresh, use this one we've got. No, we're gonna say, use Codefresh, that's great. We work well with them. We work well with Jenkins. We work well with everybody for what you're gonna do there.
We have a similar attitude about Git, right? It's like, hey, GitHub, GitLab, Bitbucket, rock and roll, man, have fun. Like those guys are going to be great at it. We don't need to reinvent the wheel around Gits, and we would rather just become the lingua franca of how do you say it? Lingua franca, the universal language, if you will, that will work with any Git. And this is also a place where I think that I've seen a lot of use cases that are Codefresh plus Rancher because there's kind of an infrastructure management use case that is very specific, and especially if you're running a lot of on-prem clusters or a lot of edge clusters, then something like Rancher is really, really valuable. And then there's also a desire to, okay, once I have my infrastructure, I want my developers to be able to manage the lifecycle of their applications without talking to me. And so something like Codefresh with Argo CD built in, they can take that and they can operate it, and they have their end-to-end lifecycle, and they can get those insights and they can manage it, and they don't have to bug the operations team for just deploying new software. This is a pattern that I've seen a lot more, where it used to be, as a developer, I build something, I huck it over the wall, operations handles it. And now it's more like, I'm a developer, I handle my application operations myself and my updates, because most of the times that it breaks, it's my fault anyway. And operations is there to catch, to help, but to provide the underlying infrastructure more so than help manage, and maybe give advice and maybe help with improving pipelines or making certain security policies enforce, those kinds of things. It feels like it's moving a lot more towards empowering developers rather than taking this stuff out of their hands.
Yeah, and I think the one place where somebody like Rancher and Codefresh will have overlap just is in that GitOps. And what do you do there? Because in the CI, we're happy to punt elsewhere, but we know that on the GitOps side, there's a bunch of people who need that pull functionality from their clusters rather than being able to push out from the master. And for that situation right now, you have Flux, which I think is simpler than a lot of the use cases. Flux is great, but it's simpler than a lot of the use cases that I've run into. And then you've got Fleet out of Rancher. And so that pull based is something that will work with us. And we've got a lot of customers who are interested in that kind of situation, just because their network setup doesn't allow for a push based situation. And so we see more and more of that. And so we are addressing it. And in fact, we've got new features around that coming in the next release of Rancher that'll be coming soon. And We've had more and more things. Fleet, now that it's under more active development, every minor release of Fleet has new features in it and more bug fixes, and it's getting more mature and more well tested. And we are targeting more of those things because that pull-based situation is something we've got, more and more interest in.
Oh, interesting. Well, that reminds me, maybe just some general news for people to be aware of. KubeCon is going to be in Amsterdam this next year, and there is a plan to do some events for Argo. There's some plans to do some events for the Open GitOps project. So watch for those for the audience. Watch for those, and there's going to be CFPs. I would love to see some talks from Fleet, from the Rancher team, on some of this exciting stuff you guys are working on at that event. And then I think obviously we talked about Argo graduated, Flux graduated. So there's been a lot of just GitOps projects getting out there. One of the interesting things with Argo CD is you got Argo CD and Argo rollouts as the GitOps components, but also Argo workflows and Argo events graduated, which is used for general pipelines and workflow engine, and using it for CI/CD is something that's becoming very common. So that's a lot of exciting news. I think this WASM stuff that you brought up is really interesting. It definitely feels like a conference that I'm going to go to next year. It feels like it's coalescing into something that's new and exciting. Coming from the TOC, do you have any other news that you'd like to share, or from the Helm project, any other interesting developments happening?
I think the only thing that I see is the space is really shifting towards lots of maturity now. And so it's the mature features that were around in other platforms are what we're seeing, which is really just enabling a lot more enterprise to jump on. The folks who are slower and a little bit more skittish, rightfully so sometimes, around security and stuff, right? Helm's mature, and we're just trucking along with release after release, adding minor features. But you see graduation of GitOps, which is a bit of a signal that it's really now for that majority, right? And especially now the early majority, the late majority, everybody, we've kind of rounded the corner on those maturity things that people need on the security front and everything else. So you see that GitOps space really having found its footing, and not just been more startup-y or more cutting edge, but for those people who have serious concerns, we've got those process and those considerations finally figured out. And, so it's great to see that's more maturity. Kubernetes hit there, Helm hit there, GitOps is hit there. And so I just see kind of a general of how do you manage your stuff is in that mature phase now. It's adulting.
Yeah, I couldn't agree more. I mean, I feel like GitOps is absolutely the best way to deploy and manage software, especially cloud native software. And I'm expecting it's going to expand beyond the cloud native more and more over the next 2 years. So with that, I think, we're a little bit over the hour, and we got to talk about a lot of topics. Matt, I think this was super cool to have you on and have you talk about all this stuff and give so much insight. You've been a pillar in this community for a long time. So honestly, it's an honor for me to have you on. And with that, I think we'll invite people, follow Matt Farina on Twitter, where he's fairly active. I would also encourage people, if you haven't joined our Discord community, we have our GitOps Champions Discord, where people talk a lot about how to implement GitOps, especially with using Argo CD, using Codefresh, using all this cloud native technology stuff. So join our Discord. If you haven't gotten certified, do the GitOps certification, because it is currently free, and it will not always be free, and very soon not be free. I won't say anything else about it right now, but that's something definitely to take advantage of. Matt, anything that you want to plug as a last plug?
I work for SUSE, so I'm going to say, come check out Rancher. We are doing some neat things these days with UI and just some of the new stuff that's coming. So keep your eyes open, because we're having a lot of fun over there. Between Rancher Desktop, Borden, Pinyo, Opni, we've been doing all kinds of R&D stuff that's really interesting, and traditional Rancher's been plugging along. So we're having a lot of fun working on some R&D and improving on the bread and butter at the same time.
I remember when Raziel the other founder and CEO of Codefresh, we were sitting around years ago, and we were talking about whether it was going to be Docker Swarm or it was going to be Kubernetes. And we were like, I bet that Rancher is going to switch to Kubernetes. And people were like, no, never going to happen. We're like, no. We think they're going to do it. We think they're going to do it. And then we think that Microsoft is going to announce a distribution of Kubernetes that they're going to manage. And it was like Rancher was like the one that we talked about as being like, that was one of the linchpins. So to see how far Rancher has come to being in this crowded marketplace of container orchestration, to becoming just such a cool company and joining SUSE and doing all his offerings, really cool to watch. And really impressed with the work that you and the team have done. So thank you again, Matt. Please stick around after the stream. We're going to end the stream there. And it looks like we had just some high fives and stuff in the chat. So we'll take it from there. Thanks, everybody. This has been GitOps the Planet with Matt Farina talking about GitOps at Edge. Take care. Bye.